So the next is about vacuum break. Okay, so vacuum break, when the vacuum surfaces will create, the pressure will be below the atmospheric pressure. Okay, when the pressure in the atmosphere is below its value, then the space is said to be vacuum space. Okay, so usually the vacuum space will be standardized with a unit. Everything has a unit, right? So the standardized unit will be saying as torque. That is over here. Okay, torque. TO or we can say in another name that is as millimeter of mercury. Okay, one millimeters of mercury is standardized as what? Torque. Okay, so vacuum space which will be represented or which will be standardized with the unit that is said to be torque. So vacuum space when it will create when the pressure is below the atmospheric pressure. Okay, so under this condition, this is classified as three different stages of vacuum. So first we will be saying it is high vacuum stage or very high vacuum stage or an ultra high vacuum stage. Okay. So when it will be high vacuum stage means when the torque, that is the millimeters of mercury, when the measurement of the millimeters of mercury will be around 1 into the power minus 3 to 1 into the power minus 6. Under this range it will be said as high vacuum condition. Okay. When it will be very high vacuum condition means from 10 to the power minus 6 to 10 to the power minus 8 of torque will be said as very high vacuum stage. Then the third ultra high vacuum stages will be denoted from, that is 10 to the power minus 9, which means and below. That is 10 to the power minus 9 and below means between the range of 10 to the power minus 8 to 10 to the power minus 9. These ranges will be said as ultra high of vacuum stages. Okay. So after knowing about vacuum, its standardized unit, its ranges of three different types of vacuum position, what you have to know is when the electrical stages will become insulation purposes, we often go for which stage means we will be using high vacuum pressure. Okay, for vacuum breakdown in a high voltage transmission line, we will be going for vacuum breakdown circuit. Under which condition we will be using the high vacuum condition. Okay, what is the range for high vacuum condition standardized unit? It will be around 10 to the power minus 3 to 10 to the power minus 6. Okay, so under this condition we will be applying the insulation to the circuit. Why we are applying for insulation there? During high transmission line, of course, there will be a insulator to protect us. Okay, to protect from any harmful effect. We are adding an insulator for every high transmission conduction line. Okay, so that insulator we are going for where? Vacuum. Even we are using vacuum insulator. This vacuum insulator we are often choosing the high vacuum insulator. Its unit is 10 to the power minus 3 to 10 to the power minus 6 of torque. Okay, are you all clear? For high voltage transmission line, insulator is must. The insulator, first we have seen either it is a dielectric medium insulator, second we have seen is a gas medium insulator, and now we are studying about vacuum medium insulator. Vacuum medium insulator, the standardized unit is represented as torque, or we can say that is as millimeters of mercury. Okay, so three range of vacuum breakdown itself are occurring. We can say three different types of vacuum pressure itself occurring. One is at the high vacuum stages, other is at the very high, and the third is as ultra high. Most often we will be going for a insulation purposes in an electrical high voltage circuit line. We will be often choosing the high voltage, high vacuum stage. That is around the 10 to the power minus 3 to 10 to the power minus 6 of torque or millimeters of mercury. Okay, so the next, what does the vacuum breakdown means? So, in the basic, we will be studying about the Townsend type of discharge. Okay, what does this Townsend type of discharge means? It is the theory about it is the electrons will get multiplied. Okay, first, whenever I am saying a high voltage transmission line, what is happening in the surrounding? With the surrounding there is an air, and due to the what process all this are occurring? Due to the process of ionization of air. If it is air as medium, ionization of air will take place. If gas as a medium, ionization of gas will take place. Okay, so the same procedure here is also occurring. Ionization process is taking place over here. What happened during ionization? The electrons are getting multiplied. Okay, the electrons are getting more in number. Okay, that is the current is getting higher value. Due to the high value of current, what is happening? Our insulator will be under certain rating. Okay, if due to some voltage fluctuation, what is happening? Current is getting to a higher value. If the current is getting to a higher value, what is happening? Sparking occurs or any other disadvantages or any other unwanted thing may occur. Okay, so one of the things we have seen in this example, that is sparking occurs. That is as corona disease we have already discussed. Okay, due to any unwanted voltage fluctuation, okay, or due to any disturbance in the high voltage transmission line, what is happening? Current is getting increased. We are saying that current increases. When the current will increases, when the electrons are getting increases, or we can say that when the electrons are getting multiplied. Under what process all this will happening? Under the process of ionization. Ionization of, if it is air medium, ionization of air. If it is the gas, ionization of gas. Here it is vacuum. Generally we can say that due to the process of ionization, what is happening? Electrons are getting multiplied. This theory comes under what means? This Townsend type of discharge. Okay, the term here it is the Townsend type. What does it mean? It is the electrons get multiplied during the process of ionization. Okay, that will be coming under the Townsend type. Okay, and what will happen is, and an electron avalanche will form. What does mean word avalanche breakdown? Avalanche breakdown, you must have been studied in your power electronics. In which diode is avalanche breakdown have you studied that? Okay, under what condition it will happen? During the reverse bias condition, what is happening when the voltage is getting increases after certain period of time, there occurs a breakdown, and after that no voltages will change. So is going to be getting increased, current is going to getting increased. Okay, still since the current is getting increases, what is happening? It is getting, we will be saying that as breakdown state. Okay, under that, beyond that value, there will not be any voltage rating about there. Okay, so the same here, an electron avalanche is going to happen, which means our voltages now get fluctuated. Current is getting increased due to the multiplications of electrons. Okay, that is what we are going to say over here. And one more thing, what vacuum stages we are seeing? High vacuum stage. Okay, so happen in a high vacuum stage, even if the electrons are first thing. Next, what we have seen here, it is vacuum. Okay, so what we are going to do, that multiplied electrons, what is going to happen means it is going to separate it. Okay, so it is going to get separated. Either we can say that as a few centimeters. Okay, so the electrons are going to be get separated for a certain few centimeters. After that, an electron process, what will happen means, I will show you the diagram for it. This is how. Okay, so if you show that what is happening means, the electrons initially flow from one conductor to the anode to cathode, cathode to, and this forward bias means anode to cathode. This procedure will happen. Okay, so what will happen if suppose voltage is getting fluctuated, current is getting increases? What is happening? These electrons get multiplied. This multiplied electrons is next to what it is going to means it is getting separated. We can say that it is going to separate it for a few centimeters. Now, if the electrons are separated for a few centimeters, we can say that there occurs what? The gap. Okay, so that gap is said to be the vacuum gap. Okay, so there is room is going to 10 minutes, and it will process a gap. Okay, so that gap is who is going to occur? Vacuum space is going to be occur. Okay, so after that certain voltages, what is going to happen means this vacuum will be getting breakdown. Okay, so already we have seen in the breakdown of gases. Okay, the point at which the breakdown occurs, that particular point is said to be what? Breakdown voltages. Beyond that only current is going to get increases. The same procedure is we are going to follow there. Okay, so three types of vacuum breakdowns are available. We will be studying that. So in the past 70 years, these three types of vacuum breakdowns are available. The first thing is we will be studying this particle exchange mechanism. Okay, how the particles are getting exchanged. That is an anode, electrons, cathode, how it is getting exchanged. The next theory we will be studying about the Freely emission mechanism, and the third theory is Klump theory. Okay, under vacuum breakdown you will be studying three mechanisms. Okay, the first mechanism you will be studying the particle exchange mechanism. The second mechanism we will be studying the field emission mechanisms, and the third we will be studying the clump theory. Okay, so under each subdivision you have to write out what does the mechanisms really means. Okay, so the first mechanism is particle exchange mechanism. From the name itself we can say that the particles are getting exchanged between the anode and the cathode. So right from the right, usually electrons flows in straight anode to cathode. The reverse flow means cathode to anode. Right? Okay, here we are not mentioning the direction. Just electrons are flow from between these two, cathode and anode. Okay, so what is happening? Particles are getting exchanged, right? So if the voltage is getting beyond the fluctuation limit, means what is happening means it will get fluctuated. It will again one more things will arrange it. Okay, so that will be through the that will forms a positive ion. Actually, electrons are what ion? Negatively. Then only we will be getting a normal flow of electron. But in case what is happening, it is getting exchanged as what? It is exchanged as a positive ion, and it is again back to the next second conductor. The next one after the second conductor is as cathode, and that is again fluctuated, or that is again particles are separated to as the secondary electrons. Now what is happening? The electrons are getting multiplied. Okay, that is we can say that two electrons are flowing between the anode and cathode. What is happening due to voltage fluctuation or due to increasing voltage? What is happening? The positive ions are created and it will get to connect to the other conductor, and the electrons are getting multiplied as secondary electrons. Okay, so this is one thing. Other thing, what will happen? What will happen? Arises in the surrounding photons. Okay, so which is also the photons, which is also the positively charged. By that also, what is happening? The secondary electrons are provided. It means the electrons are getting multiplied due to the ionization process that is surrounding the medium. Okay, so what is the main thing you have to study? Means due to the separations of the electrons, there arises a gap. That gap is said to be what? Vacuum gap. Okay, so between this vacuum gap, the electrons are traveling from one conductor to other conductor, and due to the breakdown or due to the voltage fluctuations, what is happening? The breakdown occurs, and when the breakdown occurs, at that point, what is happening? The electrons are getting multiplied due to the mechanism called particle exchange mechanism. Clear with it? You have to thoroughly draw this diagram and you have to explain this theory. Okay. The next mechanisms we will be studying about the field emission theory. So, in field emission theory, so here there is two methods. Okay, in field emission theory itself, we will be studying about two methods. One is cathode theory and another one is anode theory. First, we will be studying about the anode theory mechanism. Okay, so in anode theory mechanism, the electrons produce a small micro projections. Okay, the electrons will get a small micro projections on the where means it will be at the cathode. Okay, the small amount of electrons where it is presenting, it is in the cathode side. And due to what is the theory called? Field emission. Okay, so due to the field emission bombard, the anode causing anode will have a rise in temperature. Okay, so the straight other conductor, what is happening? Anode is getting rising in the temperature. Under that condition, what is happening means there it produces a gas. Okay, and some vapors. Okay, into the vacuum gap. Where the vacuum gap presents between this anode and the cathode. Okay, so this is separated. So anode and the cathode is getting separated. So that created a vacuum space. What we are going to say? We are going to place a electrons over the cathode, and due to the field emission, what is happening? Temperature is going to rise in the other side, that is anode side. So by that a gas is getting produced, or we can say that a vapors is getting produced at the vacuum gap. Okay, so after these electrons now will get what? Will get ionized the atoms. Okay, will ionize the what? Atoms of, if there is gas in the medium, who is getting ionized? The gas ions that is present in the gas will get ionized and produce what ions will produce? Positive ions. Same thing. The next positive ions will produce. These positive ions will arrive at what? Will arrive at the cathode. Since there is the electrons, right? So this positive will arrive at the cathode and increase the primary. This one electron, single electrons will emit more electrons. Since it is field emission. Okay, who is going to emit this more electrons? Cathode is going to emit more electrons. Okay, so due to this phase charge formation. Okay, why this increasing more number of electrons from cathode? Because there is a vacuum space over here. Okay, who is present there? Positive ions are present there. Who is going to repel want to repel that electrons which is negatively charged? So automatically it will happen. Okay. So the next it will produce what? After the primary electrons produced, it will produce more secondary electrons. Okay. So by that, who is going to be getting multiplied? Electrons are going to getting multiplied. Okay. Just you want to study the theory. By the particle exchange means particles are getting exchanged by the same principle. Positive ions are going to create, electrons are getting multiplied. Okay, so the same here, positive ions are going to be created by who means first you have to remember that in a cathode an electron is present. Okay, so the cathode and the anode, between them who is present? The vacuum gas is present. The anode, due to the field emission theory, what is happening? Anode is getting the rise in temperature. Due to the rise in temperature, what is happening? A gas is produced, or you can say that a vapor is produced in the vacuum gap. So whenever gas is produced, automatically what will happen? Ionization process will occur. Due to the ionization process, who is getting produced? Positive ions are produced. When the positive ions produce, what is happening? The electrons are getting multiplied from the cathode to the anode. Okay, so the secondary ions are getting increased. Okay, or by the bombarding the surface. This process, what will happen? It will get continuously. It will happen until the sufficient number of electrons are produced. For what? To give rise to the breakdown. To give rise to the maximum voltage where it occurs the breakdown. Beyond that, it will not go. Have you get my point? So, when this process will continues until the sufficient number of electrons are produced until it gives rise to the breakdown. Okay. So this is how who is happening? Field emission theory under anode hearing mechanism. Here who is hearing? Anode is hearing, cathode is emitting. Okay, the straight opposite you will be studying as the cathode hearing. Okay, straight opposite means opposite to the anode hearing you will be studying the cathode hearing. Okay, that who is electrons will present at the anode side. The same procedure you are going to repeat. So from the anode, the electrons are going to be, what is happening? Initially what will happen? The electron that is present in the anode, the next is what will happen? Due to the gap, the gas will be, the temperature will rises in the cathode. So by that the gas or vapor is produced in the vacuum gap. And who is going to be getting multiplied? Electrons are getting multiplied and this will continuously happen until breakdown occurs. Okay, the same theory which we are studying in the anode hearing, next we will be studying in the cathode hearing. And one specification you have to write it down, that is experimentally this has been already done. Okay, so that is the effective cathode electric field which will be in the order of values about 10 to the power 6 to 10 to the power 7 volt per centimeter, which means the gap we will be saying a gap. Okay, so vacuum already we have studied that. That is gap in what? Centimeters. Okay, we will be keeping the two conductors or a gap between for a few centimeters. I have just changed it initially told you, right? So per centimeter, what is the voltage rating there? 10 to the power 6 to 10 to the power 7 for a cathode electric field. Okay, so the next will be third mechanism or third theory is Coulomb theory or Coulomb mechanism. Okay, so in this theory we will develop on the few assumptions we will be making. So first three assumptions. Okay, so the first assumption is loosely bound particles. First, what is the word? Coulomb means the particles are loosely bound. Okay, which means you know that bounding that you all will study in chemistry lower classes itself. Okay, so clump means what? The bonding between the particles are very loose. Okay, so the next will exist on one of the electrode surfaces. Okay, that is the first assumption we have made. At the one electrode means at any of this conductor. Okay, either cathode or anode. Both are electrodes, right? Either cathode or anode. What is going to happen? This loosely bounded particles are going to be present. First assumption. Okay. The second assumption on the applications of where we are saying high voltage, high vacuum state. Okay. So here we are for applications of high voltage. What is happening? This particle will get charged. Which particles? The loosely bound particles which is present at the any of the electrode, either anode or cathode. Anode is also an electrode, cathode is an electrode. We have reference lithium ion batteries, lithium and ions are electrodes. We know that, right? From the battery which we have been studied, lithium ion battery which we have taken, lithium ion, nickel and lithium cadmium battery. We can take it as nickel cadmium battery means with nickel as an ion, cadmium is an ion. Both are electrodes. Okay, so here anode is an electrode and cathode is an electrode. What is happening in any of these electrodes? Who is going to be present? Loosely bonded particles are present. So whenever high transmission, high voltage is given to that, this loosely bonded particles, so what is happening there? It is getting charged. Okay, so on the applications of high voltage, the particles are getting charged. After that, what is happening? It is get detached from the mother electrode, which means which is the mother electrode here? This is the cathode. This is the loosely bound particle. Okay, whenever applying a high voltage across this anode and the cathode, this clump will, the clump is what? Loosely bonded particle will get detached from this cathode. Can you able to follow me? ரெண்டு எலக்ட்ரோட் வந்து ஆனோட கேத்தோட். ஆனோட்ல அப்படி இல்லனா கேத்தோட்ல உங்களுக்கு என்ன ஆகுது? ஒரு லூஸ்லி பாண்டட் பார்ட்டிகல்ஸ் இருக்கு. நான் அதுக்கு அக்ராஸ்ல என்ன பண்ண போறேன்? ஹை வோல்டேஜ் இப்ப நான் ட்ரான்ஸ்மிட் பண்றேன். அப்ளை பண்றேன். பண்ணும்போது உங்களுக்கு என்ன ஆகுது? அந்த லூஸ்லி பாண்டட் பார்ட்டிகல் எல்லாமே என்ன ஆகுது? சார்ஜ் ஆகுது. சார்ஜ் ஆனதும் அந்த எலக்ட்ரோட்ல இருந்து என்ன ஆகுது? டிட்டாச் ஆகுது. ஓகே? So next, what is detached from the mother electrode and is accelerated across the gap. Detach ஆகி எங்க தான் போகும்? Towards the gap போகுது. அந்த கேப்ல போய் ஃபில் ஆகும். ஓகேவா? So now what is happening? The breakdown will occur. Gapல whenever the electrons goes to that gap, what is occurring? Gapல electrons போனாலே என்ன ஆகும்? Insulators என்ன ஆகும்? Reduce ஆகுமா? Insulators insulating property reduce ஆக what will happen? Breakdown will occur. Initially, we have seen that the parallel plate capacitor in between a dielectric medium, or we can take a PN junction diode. What is happening? Diffusion frequency is getting lower. Automatically, what is happening? Breakdown occurring. Okay, the same principle we are going to see. So the gap is now filled with the charged particles. So automatically, the insulating property is getting reduced. If the insulating property is getting reduced, what will happen? Breakdown will occur. Okay, so the breakdown occurs due to the discharge in the vapor or a gas. Who is going to present in the between the gap? Either a gas or a vapor. Okay, so released by the impact of the particle at the target electrode. Now, who is the target electrode? If this is the source electrode, who is the target electrode? The target electrode is anode. So from here to it will target to the other electrode, that is anode. Okay, so these are the three assumptions we are going to make for a clump theory. Okay, so by explaining that, you will be drawing the diagram without explaining. Okay, so after the three assumptions, this was the first theory which is proposed by this Cranborn. Okay, he only proposed this theory and he initially assumed that the breakdown will occur for a unit. It will occur for a unit, right? For unit area. Okay, so whatever the length and whatever the breadth of that particular area, a single energy, the energy per unit area, it will occur. Okay, so next, we can say that the energy per unit energy is W. Okay, the energy is W for it will occur. Okay. So now the energy will be saying it as W, then per time. So the energy W. Okay. So that will be delivered to the, here is the energy per unit area, that is the charged loosely bonded particle release some energy and it will target to the other electrode. So will deliver to the target electrode by a Coulomb exceeds a value beyond some value. Okay, the particle will be getting charged. We are saying that it will happen when it will get detached from the mother electrode. This is to be mother electrode. Okay, this is to be target electrode. So when it will detach from the mother electrode and for a certain constant value of charging of that particular particle, that is said to be constant C. You know that how much of particle is getting charged, that is said to be constant C. That is characteristics of a given pair of electrons. Okay, so the quantity is the energy. W is the product of the gap voltage V. Here you can see the product of the gap voltage V into the charge density of the Coulomb. How much amount of the charge that Coulomb can carry? Can you able to follow me? The Coulomb is a loosely bonded particle that will getting charged. Will have a charge. Now it will fill with some charges, right? So automatically in gap, when it goes to that particular gap, it will attain the voltage V, right? The product of these two is V. We will be saying that as W energy. Clear? So W is the product of the gap voltage and the charge density. Charge density means the total charge that is carried by the loosely bonded particles. Charge that is carried by the loosely bonded particles. Okay. So the latter is the proportion of the electric field, or we can say that proportional to electric field E. So we can say that it is C is equal to V into E. The voltage across the gap into that electric field. Okay. So that is the criterion we can see for. This is how it is getting detached to the gap. Can you able to follow now? These are the three mechanisms for the voltage vacuum breakdown. So this is how after that. Now it is going to attain at the target electrode. Okay. So from the loosely bonded what is happening? Loosely bonded particles. Now firstly initially it is over here. After that it moves to the gap. Now after that what is happening? It is going to target the at the target electrode. Okay. So we have to draw this diagram for the Coulomb mechanism and you have to explain the entire vacuum breakdown here. Okay.